Welcome to Crack the Crux. Let's break the barriers to knowledge. In this video, we will crack the crux of inertial navigation. So, what is inertial navigation? Inertial navigation is a type of dead reckoning. And what is dead reckoning? Dead reckoning is the type of navigation that uses no external source. Then how does it work? Well, let me explain it to you. Suppose you're living in a big city working in corporate sector. You feel so fed up of all the hustle and bustle and long some quiet time away from the city. So, you take off from the work and leave the city. But on your way, you get robbed. The robbers snatch everything from you and leave you in a markless desert. However, before leaving you there, they told you that a city named Olivoli is 80 kilometers in north from this point. You stand there, depressed, for a long time, not knowing what to do. Then you check your pockets to know if anything worthwhile is left. Surprisingly, you find two things: 100-meter long string and a compass. What will you do now? You obviously want to go to Olivoli, that is 80 kilometers north. You use compass to find north and start walking to the north. And while walking, you keep unwinding the string. When there will be no more string in your hand, you'll know that you have covered the distance of 100 meters. And in this way, you'll cover the distance of 80 kilometers in the direction of north. For that, you'll wind and unwind the string for 800 times. But finally, you'll reach Olivoli. This is what dead reckoning is. So, what is dead reckoning? Navigating without using any external source or reference, like satellites, landmarks, or celestial bodies. Then, strings and compass? No, luckily, this is 21st century. You can use some advanced sensors, for example, accelerometers and gyroscopes. But how will accelerometer and gyroscope measure position and direction? Isn't accelerometer supposed to measure acceleration? And what this gyroscope is? Well, accelerometers do measure acceleration. But what is acceleration? Acceleration is the rate of change of the velocity. That is, acceleration is equal to velocity divided by time. And what is velocity? Velocity is rate of change of distance. That is, velocity is equal to distance divided by time. So if you have information of time, you can get velocity from acceleration as in distance from velocity. So, accelerometers gives you acceleration, which gives you velocity, which gives you distance. And distance is equivalent to position. Okay, position can be measured by accelerometers. But what about direction? If you have moved exactly 80 kilometers but not in the direction of north, you won't reach Olivoli. Well, we have gyroscope to measure direction. In fact, usually gyroscope measure how direction is changing, that is rate of change of direction, which becomes direction if you have information of time. When you use dead reckoning with accelerometers and gyroscopes, then this type of navigation is called inertial navigation. How it practically works? Inertial navigation uses axles and gyros. Axles gives you acceleration Multiplying it with time, you get velocity. Multiplying velocity with time, you get distance or position. Gyroscopes give you rate of change of direction. Multiplying it with time, you get direction or orientation or attitude. Now we know that we need accelerometers and gyroscope for inertial navigation. But the question is, how many? Let's find the answer. If this is city 1 and exactly 120 km in its east is city 2, and there's a train that goes from city 1 to city 2 without any turning. Here, we need to track train's motion only along the railway track. Therefore, we'll need just one accelerometer for navigation. However, when you're driving in a city, you can move forward and backward as well as sideways. So you'll need two accelerometers, one to track forward backward motion and other for sideward motion. Now there's another question as well. How can we distinguish whether we are moving forward or backward when there's just one axle for both motions? Well, when you're moving forward, axle will give you positive measurement, and for backward motion, it gives negative measurement. While driving, you can also make turns in the plane of road, so you'll need one gyroscope as well to detect the change in your direction, that is rotation. The gyro will give you positive measurement for counterclockwise rotation and negative for clockwise. So, for navigation in 2D, you'll need two accelerometers and one gyroscope. Now imagine you're a pilot flying an aircraft. You have much more freedom now. That is, you can move forward and backward, left and right, as well as up and down. How many accelerometers will you need now? Yes, 3. We all know that aircraft not only move linearly, it can turn left and right, it can roll, and it can pitch its nose down and up as well. So, along with 3 accelerometers, we'll be needing 3 gyroscopes as well to track these 3 rotations. For 3D navigation, we need 3 accelerometers and 3 gyroscopes. In conclusion, for 1D navigation, we need 1 accelerometer only. For 2D navigation, we need 2 accelerometers and 1 gyroscope. For 3D navigation, we need 3 accelerometers and 3 gyroscopes.